Okay, cool. So can you explain, sort of pointing out what's
This
what?
is the pulse response that is from the. This
Okay.
is the pulse sensor from the ADC, and then the Bluetooth module, and it comes out to the Bluetooth of my laptop, and
Uh-huh.
there's an built-in that virtual com. And then I use the MATLAB to receive that virtual com. For example, if you put your fingers in,
Okay.
maybe to make it not
Yeah.
not very tight, but we need
Yeah.
a little bit of pressure, and we waited um, to
Oh, I see.
let's see this part.
Yeah.
This is actually what we get, and we waited to be a little bit stable. Okay,
Yeah, you can see
and
like the
this is a
pattern.
very nicely periodic signal, and it is stable. And
Okay.
then we look at this one. These lines, each of them actually corresponds to the corresponding to that. You can see that number here, the pulse rate. It
Yeah.
is the frequency per minute. So
Right. So those are the components of.
it's now, so for example, and there's a component, and we taken out those largest pulse, and this is actually corresponding to a pulse rate, and it is showing here. And there's
Cool.
it also has another function that it for example, now you can see that these two pulses are much larger than
Yeah.
the rest.
Yeah.
And if it's that case, that is the really great case. For example,
Yeah. Yeah.
so you can say that one frequency overwhelms the other, the
Yeah.
rest,
Yeah.
and it shows that it is the
I
best
mean, what
case.
is this basically showing? It's showing what versus.
The discrete Fourier transformation of this one,
Yeah. Yeah. Yeah.
and
So basically, in what domain is the
it's
is
time
it?
domain.
Well,
It's
that's
time
in the
domain.
time. Yeah.
It's frequency domain.
Yeah. Yeah. So you're basically
Yeah.
seeing how much power is
Yeah, yeah,
on
and
this power
and
spectrum.
also I
Yeah.
do a trick that is, for example, for the discrete Fourier transformation, you cannot only get the largest pulse and say that this is your frequency, because it's
Yeah.
just discrete,
Yeah.
not continuous,
Yeah.
and your pulse is kind of continuous. So
Yeah.
I do a trick that is, I also see some kind of papers and find out a way to make it, for example, and it does that way. For it takes the largest pulse here.
Yeah.
It's actually symmetric. We can only see the
Yeah.
part of them, and take the neighborhood of them,
Mhm.
and that three numbers, and put it into the function. It can make a little shift. For example,
Yeah.
for example, for now, this is the largest pulse, and it's for if its left neighborhood is half as is large, and its right neighborhood is very slow.
Yeah.
So we have
Yeah.
to left shift it a little bit,
Yeah.